F. F is at point B, so R goes from O to B. Remember how to do cross products? When you do a cross product, is your answer a vector or a scalar? A vector. When you do dot products, is it a vector or a scalar? Scalar. So let's go back. Cross product, vector or scalar? Vector. So you're going to set up a matrix, I, J, and K. And you're going to put R, O, B, X here, R, O, B, Y here, R, O, B, Z here, and F, B, X here, F, B, Y here, and F, B, Z. So those of you who are in Math 6, you're doing these things right now, or you've already done them a zillion times. Is that correct? Those of you in Math 6? Those of you who took Math 6, it would have been a year ago. How many took Math 6 a year ago? Okay, so you guys did them too. And then you did them sometime in math, right?
5C.
Yeah? 5C? And did you did them sometime in physics maybe?
4A.
4A? So moment about O is I, J, K. Our R is 300, 500, 0. And the B is 5.6, 1.4, and 0. Okay, how do you guys, some of you do it differently. It's probably 3 different ways. How do you solve this? What are some ways you've done to solve it? Okay, Chris, you're pulling out the calculator. You just stick them in.
Yeah.
Do you just stick the thing in the matrix and press the determinant button and get it? Maybe not. You
Yeah,
take it out of your
I'm trying to
calculator for something
remember.
else?
Yeah.
Who's done it with a calculator? You press in all these values in a matrix and press the determinant button. It's not really that simple, I don't think. You don't press a determinant button, but you have to say the determinant of vector
Yeah.
A, I think. How many of you have done it that way? Okay, some of you, not too many. So that's the quickest way. What's another way, Chris?
Well, you enter it into the table, and then you have to type in like determinant.
Okay.
Yeah.
Okay, so that's the determinant
Yeah,
method.
that's
How else do you guys do it? David?
For the I component, you can cover like the whole top section and the left section, and then it's like 500 times 0 minus 1.4 times 0.
Okay, so to do the I part, you cover this and this, and you go this multiplied minus that. And then how do you get the J?
The 300 times
You cover
0.
these two and cover this, but you have to remember to put a negative in the J. Negative J, 300, 0, minus this. And then how about to get the K? You cover this, and you go 300 this minus that. Okay. Does anybody do it another way? I usually write things out because I'm liable to make a mistake in my head. Have you ever done this, where you rewrite the first 2 columns?
Yeah. I've seen that. You just draw the arrows.
Yeah, and then you go this, 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 divided by this, 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 which is, goes back to, remember, for those of you who took surveying, what was that method? Remember? Double area method? Right, so it's kind of like the double area method. Just Jill, oh, Chris, you took surveying a long time ago,
Yeah.
right? And JJ? Mark? Eric? Armando, you didn't, right?
Yeah, I took
You
it
did it?
a while
Was
ago.
it 2 or 3 years?
It was like 2.
Okay, so I usually do it this way just because when I write it out, I'm less likely to make a mistake, but you can do it whatever way you want. The quickest way is probably just plugging the matrix in the calculator. So in the end, what you get is, you get it equal to K times 300 times 1.4 minus 500 times 5.6. And it comes out to be, what value do you get? Negative 2380, is that 2,000?
Yes.
Okay, and what units are we looking at? Kilonewton millimeter. So the moment about 0.0 turns out to be this value.
So it's just,
So wait, so let's go back now to, I know it's gonna be hard to read something when it's over something else, but everybody has that number, right? I'm gonna pull this guy down. So let's see, it looks like when we did this problem, let me zoom out a little bit. When we did this problem, we found that the moment of O due to F1 is this, and the moment at O due to F2 is this. So the moment about O would be the addition of both of those. That's 4, 0. Could you add up
2404, you got it.
2404? But we just got a different answer,
But
didn't
it's,
we?
yeah, it's negative. Something like that.
2380? So these numbers should be exactly the same. And I don't think there should be much of a round, there could be a rounding error because of this.
Shot that pretty well.
You know, 5 times this, it was 3.5, so it could be that that's the error here, the rounding error.
One of your Y's used cosine 45 instead of 35.
Oh, well, I did that because remember this, we did right-hand rule.
Oh, gotcha.
So, right, so it's absolute values, so I didn't care if I had a negative or not. Right, these are all absolute values. Good point, though. I have a feeling it's a rounding error, but these should be exactly the same. So this way, we did a 2-dimensional problem using the right-hand rule, and here we did the same 2-dimensional problem using vectors.
and this should be the same because it's static.
They should be the same because there are 2 ways to determine a moment. You determine a moment by 2 methods. This moment. This is method 1. Actually, I'm going to call this method 2, and this one is method 1. 2 different ways of doing it. Now, you might feel that the right-hand rule method takes longer than the vector method. You might like this method better because it's cleaner and you guys have done so much stuff with vectors. But as we move in along in the class, you're going to see that the right-hand rule is much better to do because you're getting a physical feel for what's happening. When you find an R vector and find an F vector and then find the determinant of them, there's no thinking involved of what physically is going on. You're just plugging and chugging and you get a number. Oh, and what did I leave out on here? I left out the K, right? When you do the right-hand rule, you're physically understanding that this force is creating this moment about this bar. And it's more of a physical sense. And you're going to get better and better and better at it. Wes?
So the units on that, it's like, that's just kilonewtons, right?
That's kilonewtons millimeters.
Which
Because it's
is
a moment. This is the K for
direction. Okay.
Okay.
That seems like, I mean, that's 2,000
Okay, so-
newtons per millimeter.
But
That seems
millimeter,
like
right? So let's convert this. Let's say kilonewton meter. That's 2.38, right?
Okay.
Kilonewton meter, is that more of a comfortable feel? I think that you guys might have a better feel of metric than I do. In engineering, we still use metric and we use English, so I still have a better feel for English. I don't remember what I did when I was in physics in college, but that was quite a number of years ago now. But you're coming out of physics where that's all you do is metric, right? So how many kilonewtons to a pound?
Not having enough.
Oh, so you you guys don't, do you have a feel of what a kilonewton is? What?
That's Newton meters. Kilo is 10 to the third, milli is 10 to the negative third. That's Newton meters.
No, it's not. I changed it from millimeters to meters, so that's, I had to go over 1,000. If you want to make this Newton millimeter, then it would be, go back to this. I took kilonewton millimeter and I changed it to kilonewton meter, which is going to make this number smaller by 1,000. If I now want to go to Newton, it's going to make it bigger by 1,000. So 2,000 newtons, do you guys have a good feel for what a newton is?
No.
You know how I judge
That's
all my
small.
weight? I worked in an ice cream place when I was in high school, and a box of sprinkles was 25 pounds. And that's how I remember, you know, when I lift something, I know if it's 4 times the sprinkles or not. Maybe that's really weird. I don't know how you guys have a judge, but that's all based on sprinkles.
I was just saying, it seems like a lot, like a rotation on whatever is holding it on that wall.
It's
You know,
huge.
it's usually.
Yeah, but we're thinking, we're talking about steel, right?
Yeah.
Steel could be amazing. I mean, I could take a 1/4 of an inch steel rod and it's pretty damn strong. It's gonna be able to take that rotation, not a problem. And if it can't, well, then I'll make it a 1/2 inch or 3/4 of an inch or whatever. Peter?
So 1 kilonewton is 225 pounds.
Okay, 1 kilonewton, let me write it down. 1 kilonewton is 225 pounds?
Yeah, 224.
Okay, so wait, so 1 newton is what? 1 newton would be, oh God, that's too big then. I have to add 1,000, right? Is that right?
It's the other way.
Is that right? Okay, well, we're never gonna deal with newtons then, because that's just too big a number.
Yeah.
Right, didn't I do this right? If 1 kilonewton is 200 pounds, then 1 newton's 225,000, so forget this.
Oh,
You
no.
divide by 1,000.
I was wrong?
I believe.
Other way, right?
Yeah.
You gotta divide by 1,000.
Oh, yeah, right. So it's point,
That makes sense.
They're really small.
okay, so 1 kilonewton, let's just say is 200 pounds, just for me to remember a number. And 1 newton is 1/4 of a pound,
Yeah.
right?
So I'm gonna throw a chicken
Throw the scale and
it's about
Okay, so everybody sees the 2 different methods, right? And we're gonna be able to do them in both 2D and 3D. So if we go back to what the homework number 5 is,
Okay, so 2D and 3D, did you want us to use the right number?
both, you'll see, watch.